Hello colleagues, this is Arda from Weekly series, and today we are going to discuss our latest article, namely Building the Efficiency Frontier. I just wanted to mention here a different concept, a different calculation methodology, namely the data envelopment analysis, and also it contains a term efficiency frontier. And let us try to understand how we can use this concept in as a lean improvement method. So before I go too much into the calculations, I just want to mention a little bit about the efficiency, which is a tricky concept. As you may remember, maybe from the original Lean series, we had covered the cost world and the throughput world, and there were differences between these two worlds, these two different points of view in terms of financial analysis. And sometimes, especially from the cost point of view, there can be incorrect decisions from the operational leaders, especially in regarding the efficiencies. So, for instance, if you want to have a high amount of resource utilization but you do not have a flow efficiency, sometimes you may go to incorrect decisions like just because you have got some resources, try to utilize it and create additional inventories and disruptions, sometimes manufacturing unnecessary parts that you may not will need in your production in serving the customer. So when we talk about efficiency, we are talking about the efficiency when we want an adequate amount of resources that we do not want to waste, and the production flows to customer without disruptions, without very much different types of inventories, high inventories also, and the production flows to the customer in accordance with the customer tact. And with this kind of an environment, we want to focus on the efficiencies to understand we are using the resources without much waste. So we want to think of the efficiency concept in this fashion, not in the other way around. Just because you have got some kind of resources, just trying to utilize them does not mean efficiency. Actually, it does not make much of a sense. So we want to have an efficiency in a flow environment where we are trying to serve the customer the necessary goods, the products in accordance with the flow to the customer, in accordance with tact and without disruption. So having said that, of course, it is very crucial to monitor and understand the inefficiencies of different units in a manufacturing environment, especially if they are the bottlenecks, because as you know, if there is a loss in the bottleneck, it means the loss of the entire value stream. It is very costly, and so the efficiencies in a bottleneck process must be closely monitored. You should not waste resources in a bottleneck. Also, you should not waste resources in any other process. And also, you need to understand the root cause of the losses and track them to solve them. Again, our aim is not utilizing resource, but it is not to waste resources of both machine equipment and operators while maintaining an undisrupted production in a flow environment. In here, we have to mention the overall equipment effectiveness. The OEE figure is very much crucial in understanding what is going on in our facility in terms of the availability and the performance and the quality of each different unit. And OEE is the industry standard in understanding the efficiencies in the manufacturing area. So OEE is an efficiency figure, and it is simply focused on how well we are converting the planned operating time to good products as an output, and simply output over input gives us how well we are doing this job in using our available time. So OE is an absolute efficiency figure. It simply focuses on wastes inherent to process and track them. But here I want to make a parenthesis, especially from my experience, from what I have seen in different organizations. Sometimes this OE tracking can be misleading, especially if you are a little bit moving away as an organization from the lean culture. There can be times in organizations like that not everyone can be or will be willing to show their departments, their units in a way that does not look good on paper. So in this kind of a situation, you may find that many of your planned downtimes are not actually planned, or you may find OEE figures like closing to 100%, but when you go down to the shop floor, things are not looking that bright. Even if you have an automated process to measure the OEE figure, it can still be manipulated, misunderstood, etc., etc. So if you have got enough collaboration from the shop floor, and if your lean culture is moving a little bit away from lean, then you will have issues with the OEE figure, especially the capacity from the capacity aspect. So then here comes a different perspective, which is the goal of this article. We have got this data envelopment analysis. It is actually not a new technique. It was first introduced in 1978 by Chance, Cooper, and Rose, these three great mathematicians. And basically, it tries to understand the relative efficiencies of different DMUs in accordance with their own efficiency frontier. Let me get a little bit more clear on that. For instance, you have got a machine park that involves several different units, and simply you want to understand who is doing how in terms of efficiencies. Say you have got two different outputs and one input as X, and two different outputs as Y1 and Y2, and you just take into account the historical usage of these inputs and their corresponding output, and simply put it on paper. As you may see in this good simple representation, some of the DMUs will be performing much better than others. So they will create an efficiency frontier, and it means that these are the best performance. So with this kind of analysis, you may simply be curious about, hey, okay, this DMU is going well, but what about its counterpart here? There are quite a lot of difference in terms of performance, and this will be an issue. So here you are not talking about absolute efficiencies. Here you are not talking about planned or unplanned downtimes, percentages. You are simply saying that this corresponding same type of process was performing well better than another process which is more or less similar. So the benchmark or the corresponding difference in this performance should be addressed too, because here you are not talking something about absolute. It is still you have got the same process in your own machine park. Maybe they are very close to each other. Simply these guys should go and benchmark these guys in doing whatever they are doing, and it will create a very better understanding in the process itself. So so this is a good elegant way to understand what is going on in your shop floor. And I just wanted to put a good clear example, a little bit on the nose maybe, but it is doing the job. For instance, you have got two inputs, labor and material, and one output, product. And you can simply put up a graph and see that, for instance, in this example, DMU1 and DMU4 is clearly creating an efficiency frontier versus DMU3 and DMU2, because they are simply using less inputs to create more output. But of course, we need to understand that there can be more than two inputs, more than two outputs of units. So if that is the case, you can use simplex algorithm in also even in Excel, and simply solve the problem as a simplex problem, and you will still get the relevant efficiencies of each DMU. So even if you do not have a good, clear graphical representation in that case, because if there are more inputs and more outputs, then this this chart will not help. You can still solve it as a simplex problem and see the results for yourself. It is very easy actually. Maybe I just share this small example. Here you can see a solved version. Here, these are the simplex changing variables. You just plug in the output, labor, material, and efficiency figure, weighted output, simply multiplying the weights with outputs, and the same also for the input. And also here, you should solve it for all DMUs. By the way, how many DMUs you have got, you should solve the same simplex algorithm. Here you plug into solver whatever you are going to maximize is an objective. Here, for instance, we are solving for DMU2, and changing variables are here the weights, and here are the constraints. The constraints are coming from this CCR model, the Cooper, Charnes, and Rhodes model in this formula. It is not as complicated as it looks. As simply it says maximize the output versus input, and just to make it linear, you go and change a little bit of these representations, and you will get this way of representing the simplex formula. The efficiency is simply differences division between output over input, and so you maximize your efficiency in accordance with these constraints. So you just plug it in. You are doing a simplex LP and solve it. So the solver gives you a result. I'm sorry, I will just reconstruct it. Okay, and now you are going to see that the DMU1 and the DMU4 is well outperforming these DMU2 and DMU3. You will get the same result of efficiency for all the four analysis that you are going to do. And it is very simplistic to see that with one simplex solution, you will get the same result for all DMUs. Just to make sure you can solve for one or two or more DMUs and see the result for yourself. So these are these three great mathematicians that have created this beautiful technique: Mr. William Cooper, Mr. Abraham Charnes, and Mr. Edward Rhodes. And I think it's a good idea to check the absolute, to check the relative efficiencies instead of absolute efficiencies, just to see what is going on in our shop floor in terms of our own efficiency frontier first, because most of the time when we confront problems like inefficiency, there are many discussions between the shop floor responsibles and efficiency responsibles, operation excellence responsibles. There can be issues like the machine is old, that machine is new, etc., etc. But simply just putting together similar machine relative efficiency frontier, you will show everyone that there are differences in terms of shop floor activities. And since it is already in your own shop floor, it is your own efficiency frontier. It is not something about an absolute figure. You don't tell them you to go from 60% to 100%, but simply say there is another same process in your own area, in your own shop floor. Just simply go and check whatever they are doing different than you are, and help them understand the differences and take rational and usable actions. So having said all of these, I think this can be a good way to understand the relative efficiencies in a shop floor. So always let us keep in mind that every new improvement will create a new frontier for us. So our frontier will always be dynamic, I hope. So I think this can be a good alternative for us to understand what is going on in our shop floor. So thank you all for viewing, for checking my article, and see you next time in another YouTube channel video. Bye-bye.